Hi guys, this is Mrs. Kreifels, and we are getting ready to start Chapter 2. Chapter 2 is more about reasoning and kind of thinking about if something is true, whether something else is or is not true based on the original fact. So what we're going to start with is what's called some conditional statements. Conditional statements are basically just statements that say, if something, then something else. Okay, so if you notice, all of these 7 statements on here are in the form of if then. What I'd like you to do is pause the video really quick and take a minute and decide if you think that it is true or false. And if it is false, then I would like for you to give an example that proves it wrong. This is called an example that proves something wrong, and we'll learn more about this later, is called a counter example. So if it is false, I want you to see if you can come up with a counter example. So go ahead and pause the video, read through them, think about it, decide if they're true or false, and then if it is false, give a counter example. Okay, hopefully you've had a chance to do that. And let's take a look. So if yesterday was Wednesday, then today is Thursday. If you think about it, is there any other day that comes right after Wednesday? No, that's not possible. So this one would be a true statement. And if it's true, we don't need to come up with any example or anything. We just say that that's a true statement. Okay. If an angle is acute, so I'm telling you the angle is acute, then it has a measure of 30 degrees. Well, it could have a measure of 30 degrees, but if it's an acute angle, it could also have a measure of 20 degrees or 50 degrees or anywhere between 0 and 90, not including 0 and not including 90. So this one would be false. And all you'd have to do for a counter example is just say, oh, well, it could be 25 degrees. That's acute, okay, but it's not 30 degrees. Okay, the third one makes you think a little bit about how much you really know the calendar. But if a month has 30 days, then it is June. Yes, June has 30 days, but is that the only month that has 30 days? No, it's not. We could list out, let's see, April has 30 days. September has 30 days. November has 30 days. So there are several counter examples for that statement. If it is cloudy, then it is raining. Okay, well, it does help to be cloudy to make it rain. However, I'm sitting in my room right now looking outside and I'm thinking it is very cloudy out and it is not raining. So that one would be a false. It can be cloudy without rain. If you live in Nebraska, then you are a Husker fan. And I am sure there are many of you listening to this that would disagree with that. Although I am a Husker fan and live in Nebraska, that's false, because you could live in Nebraska and still be a, I don't know, Texas Longhorns fan or Notre Dame fan or anything like that. So any time that you're a fan of anybody other than the Huskers, you could be a counterexample. The next one, if it is snowing, then it is winter. Okay, if any of you know the crazy weather in Nebraska, you know that we have had snow all the way in through May. I remember one year it snowed in May. So, and May is definitely not winter. It's also snowed in October, April, so it does not have to necessarily be winter in order for it to snow. And then the last one is if a polygon has 3 sides, then it is a triangle. Okay, is there any other 3-sided shape that is not a triangle? No, so that one would be true. And if it's true, there's no counterexample. So I didn't actually write counterexamples down for all of these, but any of those things that we talked about, you just put it into words as an example. Okay, so what we are going to focus mostly on is what's called conditional statements. And again, a lot of geometry is logic. So these are logical statements. Oops, I meant to highlight that. So these are logical statements. Okay. And they have 2 parts. The hypothesis. Okay, so the hypothesis is basically the if, and the conclusion, which is basically the then. So what they do is they put that with these little notation types of things. And if P would be the hypothesis, and then Q is the conclusion. Okay, they always use P and Q, not sure why, but they always use P and Q for the hypothesis and the conclusion. And then if you see it with an arrow drawn in between, like this, that just means, that also says if P then Q, or you could say P implies Q. So we're going to look at several different conditional statements here and the different parts of them. Okay, so all we want to do here is underline the hypothesis, circle the conclusion. Remember, the hypothesis is the if part, the conclusion is the then part. So this is really simple. So if an animal has feathers, so we're going to underline if, the hypothesis, and we're going to circle the conclusion. Notice I did not put if or then, it was not underlined or circled. If you are in Springfield, then you are in Nebraska. If you are in Springfield, then you are in Nebraska. Hypothesis, conclusion. Okay, again, this is just the same basic thing again. It says if an angle is 30 degrees, hypothesis, then it is acute. Conclusion. If an angle is obtuse, then it is 145 degrees. Conclusion. Notice we are not deciding whether these statements are true or false right now. We are just looking at the parts of the statements, which is the hypothesis and conclusion. Okay, the negation, okay, anytime you negate something, you're making it the opposite, basically. So the negation is the opposite of the original statement. And in words, we say not whatever it is. So if it would be the room is not dark, that would be a negation. The symbol for it is this little squiggle mark right here in front that looks just like that. And it'll just say, that just says, so if it's like that, not P, that says not P, or not Q, or whatever it happens to be. So then we just want to negate each statement. Remember, the negation makes it the opposite. So the ball is red. We are not going to change the color of the ball. We are just going to say that the ball is not red. And that would be the negation. If we say the cat is not black, again, we're not changing the color of the cat. We are just saying the opposite. So we are going to say the cat is black. I mean, technically, if we wanted to say it, we could say the cat is not black, but not just means the cat is black. Okay, so now here's some new vocabulary for you. We have the conditional statement, which is just that basic if-then statement that we've already talked about. So the conditional statement, again, is just the original statement, if P, then Q. Okay, now we have the converse. The converse, if you notice, says if Q, then P. All that the converse does is it switches the order of P and Q. And we'll look at these examples in words, which will help you make a little bit more sense of it in just a second. And then the inverse takes the conditional statement and negates both parts. Okay, so that negates both parts. And then the contrapositive takes the converse and negates both parts of those. So the conditional and inverse is the conditional and the negation of it, and then the converse and the contrapositive is the converse and then the negation of it. So let's look at an example in words. Okay, it says let P be you are a guitar player, and let Q be you are a musician. Write each statement in words, then we need to decide whether it is true or false. So we're just first of all going to write the original statement, the conditional statement, in if-then form. If you are a guitar player, then you are a musician. Okay, so let's think about that. If you are a guitar player, then you are a musician. Okay, well, by definition, I think in order to play music, you have to be able to play something. So in this case, if you are a guitar player, then you are a musician would be a true statement. Okay, now the converse just takes that and flips the order. Okay, so the converse is going to be if you are a musician, then you are a guitar player. Okay, so let's think about that. If you are a musician, then you are a guitar player. Well, if you are a musician, do you necessarily know how to play the guitar? Not necessarily. Sometimes a musician might play the piano or might play the trumpet or something like that. So in this case, the converse is false. Okay, so then we're going to do the inverse. The inverse takes our original statement and negates both parts. Okay, so let's write the inverse, which is going to be the negation of our conditional. So if you are not a guitar player, then you are not a musician. Okay, so let's think about that for just a second. If you are not a guitar player, okay, I'm not a guitar player, then you are not a musician. Well, just because I don't play the guitar doesn't mean I don't play something else. So this statement, if you are not a guitar player, then you are not a musician, is a false statement. And then the last one is the contrapositive, which basically takes the converse and negates both parts of it. So the converse was if you are a musician, then you are a guitar player. Okay, so the converse, or excuse me, the contrapositive is going to be the negation of that. If you are not a musician, then you are not a guitar player. Okay, so if you haven't noticed already, this chapter is going to have a lot of writing. It's not going to be a lot of algebra and a lot of math type of stuff. It's reasoning, which is going to require sentences and a lot more writing than normal. So just one of those things to give you a heads up about. But so if you have the contrapositive, if you are not a musician, then you are not a guitar player. And if you think about that, if you're not a musician, that means you don't play anything. That means you're also not a guitar player. So that would be a true statement. So what we're going to talk about next is how these things work out. So if I say that I have my conditional statement, if my conditional statement's true, whatever my conditional statement is, if it's true or false, then my contrapositive is also going to be the same thing. So if the conditional statement is true, your contrapositive will always also be true. If your conditional statement is false, your contrapositive will also be false. And it goes the same way with the converse and inverse. If one of them is false, they're both going to be false. If one of them is true, they're both going to be true. All right, so what I'd like for you to do is write your own conditional statement, then write the converse, inverse, and contrapositive and decide if each is true or false. And then we are going to share these out after everybody has a chance to finish it up. Maybe it'll be right before mass break or right after mass break, depending on how the time goes. But I want you to go ahead and write it, and I'm going to ask people to share it here in just a little bit. Thank you. And the other thing I remembered I should probably mention is what your homework is. So your homework, after you watch, there's this lesson video and then there's a part 2 that goes with it. So you don't have any homework you have to do right now. There's actually a worksheet in Schoology that's Chapter 2, Section 1, Part 1, and Part 2. There's one worksheet that goes along with both parts. So once you finish Part 2 of this section, then you can go and do that part of the homework.